Welcome to another episode of the Bug Bite, hosted by your shitty tech coach Ralph, where we're engineered to win. In this episode of the Bug Bite, we are going to be talking about, oh my goodness, environment files, .env files, and AWS being exposed. Say it ain't so, say it ain't so. This is always one of my greatest fears when I'm developing is that our .env files are not secure, and why the hell are they being uploaded onto the web servers anyways? Not good at all, not good at all. People need to learn how to actually use these .env files. But before we jump into it, do me a big favor. If you haven't done so already, like the video, share the video, subscribe to the channel, hit the notification bell so you know every time that we go live and drop new content, as well as go to techcoachrap.dev, get access to exclusive content to help you level up in your career, as well as your technical skills, learning how to do job researching and all of that good stuff, as well as get the opportunity to work one-on-one with me, where I can coach you and help you grow in your knowledge and your skill set. Work with us together so you can run it up and make it to the next step. With that being said, let's jump into this story about the AWS the environment variables on AWS being shared and being stolen. It's a nightmare. It is a total nightmare. Let's find out what happened. All right, so this article is written by Lucien Constantine. It is this article is brought to us by CSO Online. He is a CSO senior writer, and the article is titled AWS Environments Compromised Through Exposed .env files. So this article was published on August 22nd, 2024, a little over a month ago from when I'm reviewing this. So attackers collected Amazon Web Service keys and access tokens to various cloud services from environment variables insecurely stored in tens of thousands of web applications. So quick context, what is a .env file? So typically a .env file is used. I think you can use it probably you can use it across like pretty much any coding application. And basically, I know definitely in Node, I use it all the time, but I use that for local development. I don't ever upload the .env file to the web server. So the .env file is storing environment variables. You can have access to databases, access to various cloud environments, access to whatever. It's an unsecured file. I always add the .env file to the gitignore file so that it is not pushed up to the cloud. It's a big no-no. And this seems like this is what's happening here, right? So let's dig into it. A data extortion campaign that compromises AWS resources through credentials collected from environment.env files stored insecurely on web servers has been uncovered by Unit 42 researchers. The exposed files contain AWS access keys, credentials for databases and social media accounts, API keys for SaaS applications and email services, as well as access tokens for a variety of cloud services. The operation was uncovered while researchers investigated a compromised AWS environment that was being abused to launch automated scans against other domains as part of this campaign. The researchers determined that the attackers collected .env files from about 110,000 domains, leading to the exposure of over 90,000 unique environment variables, with 7,000 corresponding to cloud services used by organizations. This is a total nightmare. So one of the when passing in environment variables, right, you should never ever push the .env file to the cloud. What you should do when you're starting up your application, however you're starting it up, you need to pass those environment variables to the application, whether you're starting it in the command line or something like that, but you need to like manually pass those in there so that it is not having a file that is stored with all your environment variables. I remember when we were working on the Terraform, learning Terraform on Sundays, I used AWS secrets in order to store the location to different database and stuff like that, but I did not have just a loosey-goosey .env file that has all the credentials. It's a total nightmare, right? Not all the leaks necessarily contain user accounts or secrets, but all of them leaked some detail about a victim's internal infrastructure or its configuration, the researchers said in the report. And here's the thing: the more information you just providing some information is dangerous enough, right? And they can start to try to figure out a way in. These hackers they just need one thing, right? Examples of the leaked credentials included 1,185 unique AWS keys, 333 PayPal OAuth tokens, 235 GitHub tokens, 111 HubSpot API keys, 39 Slack webhooks, and 27 DigitalOcean tokens. Oh, what a mess. What is this? Why is this lady stalking me here? Let me see. Can I get rid of this thing? Let's go like that. Let's stop her. All right. So AWS services and infrastructure were not affected by the findings outlined in the research, according to an AWS spokesperson. The issues described in the blog were a result of bad actor abusing misconfigured web applications hosted both in the cloud and elsewhere that allowed public access to environment variables .env files. So I'll say this, right? I'll say this. Yes, there are bad actors, but there are also very, very poor development and security skills. Just because the actors were being nefarious and stealing data, but you put the data out there. You put the data out there. So we have to do a better job. Of yes, bad actors, but let's not do stupid development practices as well, right? Some of these files contain various kinds of credentials, including AWS credentials, which were then used by the bad actors to call AWS APIs. So environment variables exposed due to misconfiguration. Multiple web development frameworks and web applications store important configuration data inside .env files. No, they do not. See, I disagree. They do not store it inside of .env files. The developer chooses to create a .env file locally, and then they push it up to wherever they're hosting, right? And that's not good. We need to be able to pass them separately and in a secure manner. So this could include credentials and API keys to third-party services and resources that the application needs to function. Web servers should be configured to prevent access to dot files and default. By default, because these are supposed to be hidden files that are never intended for public access. However, misconfigurations happen all the time. Another example is the .git folder, which stores important configuration information for the Git source code version control system. I have to look into that one. That one I wasn't aware of. The accidental exposure of .env or .git files is a known issue that other researchers have warned about in the past, so it's not unusual for attackers to run web crawlers looking for such exposed files in the root folder of domains. However, the scale of the operation uncovered by Palo Alto Networks Unit 42 suggests that such misconfigurations remain widespread. You know what? While we're even talking about it, let me check my. Do I have a .git file? And is it? Let me see. I have a .gitignore file that is hosted, but I do not see a .git file. So maybe that's ignored. Let me double check. You never know what's going on over here. I don't see it. So I'll look into that some more later. But anyways, let's keep reading. Let's see. So lateral movement inside AWS environments. In the hands of knowledgeable hackers, leaked secrets can be very powerful and dangerous. For example, the attackers behind this operation exhibited advanced knowledge of AWS APIs. After obtaining an AWS key, the attackers used it to run a get caller identity API call to verify the identity or role assigned to the exposed credential. They also performed other reconnaissance actions by calling list users to gather a list of IAM, Identity Access Management users in the AWS account and list buckets to identify all existing S3 buckets. Whew, this is crazy. In the compromised AWS environment investigated, the attackers realized the exposed AWS IAM roles they obtained did not have administrative privileges over all resources. However, it had the permission to create a new IAM role and attach IAM policies to existing ones. They then proceeded to create a new role called Lambda X and attach the administrator access policy to it, achieving privilege escalation. Oh my God, these people are geniuses, my goodness. Following the successful creation of the privileged IAM role, the threat actor attempted to create two different infrastructure stacks, one using Amazon Elastic Cloud Compute, EC2 resources, and the other using AWS Lambda. The researchers said by performing these execution tactics, the actors failed to create a security group, key pair, and EC2 instance, but they successfully created multiple Lambda functions with newly created IAM role attached. AWS Lambda is a serverless computing platform designed to execute user-supplied application code on demand. It has been abused by attackers before for crypto mining with miners written in Go, but in this case, the hackers used it to deploy a bash script that would scan other domains for exposed.env files, extract credentials from them, and upload them to a public S3 they previously compromised. So, I mean, they're just connecting everything together. They got into one area, and then they used that to create a Lambda with certain privileges, and then use that to gather more data, steal more data, and then upload it to a public S3. That particular script was looking for credentials for the Mailgun email sending platform, but by accessing the attacker's publicly exposed S3 storage bucket, the researchers were able to understand the full scope of the campaign. We identified more than 230 million unique targets that the threat actor was scanning for misconfigured and exposed environment files. At the time of access to the public S3 bucket, we estimate that multiple compromised AWS accounts were the target of this malicious scanning as part of a compromised automation operation. This is genius. Like, they are evil geniuses. Right? So let's go to the data exfiltration part. So data exfiltration and extortion. Whenever they manage to gain credentials to S3 buckets, a popular data storage option for many web applications, the attackers use a Windows tool called S3 Browser to interact with the S3 API and exfiltrate all the data from them. Oh my God. After all files were downloaded, the attackers deleted them and left a ransom file behind, informing the owner that they now have access to their sensitive information and plan to sell it if they are not paid. Oh my goodness! So they made a copy of the data, and they said, all right, if you ever want to see this data again, wire this much crypto to this address, or however crypto works, right? The threat actor accessed AWS accounts and S3 buckets from the Tor anonymity network, public VPNs, or from inside the AWS infrastructure itself using other compromised accounts. However, the researchers detected two instances where the attackers connected directly from IP addresses allocated to ISPs in Ukraine and Morocco. What the? So researchers suggest remediation. Palo Alto Networks researchers advise organizations to have S3 logging or CloudTrail logging for the S3 buckets events to be able to perform forensic investigation if an incident occurs. These settings are not turned on and might increase the cost for the cloud environment because they use resources, but they are worth it to be able to accurately assess what happened in case of compromise. Depending on the AWS service used, organizations will want to ensure they enable the specific logging unique to that service. The researcher said, after organizations establish the proper logging and retention of that data, 90 days minimum retention recommended. Then the focus shifts to monitoring those data sources, right? All right. So AWS Guard Duty Service provides some alerting features for credentials and EC2 resource abuse. Organizations can create their own alerts for abnormal activity inside log data. We definitely have to look into Guard Duty. That's my first time hearing of it. I'm very curious to see how it works and see what we can figure out, what we can glean from there. The researchers strongly advise against using long-term IAM access keys in applications and instead rely on IAM roles, which only provide temporary access. The principle of least privilege, we spoke about that when we were talking about DevSecOps. The principle of least privilege should be followed when configuring access to IAM resources so that attackers can easily perform privilege escalation. Or lateral movement. Access to unused AWS regions should also be disabled so attackers can't deploy resources in additional regions. The AWS spokesperson warned that environment variables should never, ever, ever, ever be publicly exposed, and even if kept private, should never contain AWS credentials. AWS provides a variety of easy-to-use mechanisms for web applications to access temporary AWS credentials in a secure fashion. We recommend customers follow best practice for AWS identity and access management to help secure their AWS resources, right? So that's that. Like I said, this article is written by Lucien Constantine and very, very informative, very, very helpful. Let's go back to full screen before we wrap this up. So there you have it. There you have it. One of the what a tragedy to read about how these hackers stole all this AWS data. But you got to be more careful. You can't be exposing your .env files. Don't go exposing your .env files. It is a recipe for total disaster. All right. But that's it for today. We're going to wrap it up. Thank you guys so much for tuning in to another episode of the Bug Bite. Before you head out, do me a big favor, like the video, share the video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content, as well as go over to techcoachdrop.dev. Sign up today for free. You can access to exclusive content that will help you level up in your career as well as in your technical skills, and you can work with me one-on-one. Sign up today, one-on-one coaching. Let's run it up together. Let's level up. Let's level up, right? Techcoachdrop.dev. Sign up today for free. And with that being said, we're going to head out. Thank you guys so much for tuning in. Have a wonderful rest of your week. Have a wonderful weekend. This is Tech Coach Ralph with another episode of The Bug Bite. We are out.